I just wanted to post a short video going over the graphing final assignment for the four of you that did it. So if you're watching this, congrats, thanks for doing it. If you're watching this and didn't do it, maybe try it out. I don't know. Um, Number one, there's $500 in Holly's bank account. She takes over $50 from her account each month, but doesn't put any back. Make a table of values for up to 6 months. Everyone got this question right. This part pretty easy, right? Starts at 500, goes down 50 each month. You literally just go 450, 400, 350, 300, 250, 200. Simple. I'm not going to talk about that. Writing an equation is where some of us messed that up. Everyone got the plus 500 right as the constant, right? Because you're starting at $500, so that's where your constant's going to be, 500. But what you guys got wrong, a lot of you, is the rate of change or the multiplier, right? The rate of change should be negative 50. The equation is y equals negative 50x plus 500. How did I get negative 50? I used that y2 minus y1 divided by x2 over x1 method, right? So for example, y2 is 200, y1 is 500, 200 minus 500 is negative 300, x2 is 6, x1 is 0, 6 minus 0 is 6. Negative 300 divided by 6 is negative 50. So that's why our multiplier is negative 50. And that makes sense because it's going down 50 each time, right? Negative 50 is our rate of change. So this is the equation. Y equals negative 50x plus 500. Is this relation partial or direct variation? It's partial because there's a constant, right? The plus 500. And it goes through the point. It does not go through the point 0, 0, right? So it doesn't go through 0, 0, so it's automatically partial variation. How much will Holly have in her account after 8 months? We'll just plug 8 into the equation that we made where the x is, right? Because x represents months. Y equals negative 50, put in the 8 times 8 plus 500. Negative 50 times 8 is negative 400, so y equals negative 400 plus 500. Y equals 100, right? So after 8 months, Holly will have $100 left in her bank account, which makes sense because that follows the chart we had, right? At 6 months, she had $200 left. She loses 50 a month, so at 8, she's clearly going to have $100 left in her account, right? Makes sense. This is the trickiest question probably, part F. How many months will have passed when Holly has $50 in her account? Show your work. It's easy just to know, well, if she loses $50 a month, I just calculated after 8 months she has 100 left, so the answer is 9. Yes, you're right, 100% the answer is 9, but it wants you to show your work, and that's going to be a little tricky because it involves some parts of algebra that we haven't covered yet. We're going to cover it in about a week, so I wanted to show you how the right way to do that question is, right? So our equation was y equals negative 50x plus 500, but it wants to know how long will have passed when there's $50 in the account. So you have to understand that in our equation, y equal or represents is the same thing as money in your account, and x represents or is the same thing as amount of months passed. So if I want to find how much months have passed with $50 in her account, I have to put the $50 in for y. So instead of y equals negative 50x plus 500, it's 50 equals negative 50x plus 500. And then we use the laws of algebra. If I'm adding 500 on this side, I can move it over to the other side of the equal sign, but now I'm subtracting it. So 50 subtract 500 equals negative 50x. This now disappears because I moved it over to this side of the equal sign. 50 minus 500 is negative 450 equals negative 50x. And this goes back to what we did at the start of our class in February, our proportions, right? If I have negative 50x and I want to get rid of the negative 50, I got to divide it by negative 50. I got to divide the other side by negative 50 as well. Negative 450 divided by negative 50 equals 9. So x equals 9. After 9 months, she will only have $50 in her account, right? You could have got that answer without doing all that math, 100%, and most of the time I'd be like, that's cool, do it that way. But this just wants you to show your work and practice using algebra skills, so that's kind of why I want to do it this way and show it to you. We're going to do more of this kind of stuff this week and next week, so don't worry if you didn't get what I just said. I know I went over it pretty quick. We're going to spend more time doing it, all right? Question 2, Tasha is just learning how to snowboard. White Mountain charges $10 an hour. Make the table. Once again, you guys all got that right. Starts at $40, so you're paying that for your rentals no matter how long you're there. And then $10 for each hour of lessons. So it starts at 40, and for every hour you're there, it goes up by $10, right? Pretty simple. What's the equation? Well, it's y equals 10x plus 40. How did I get that? Well, it starts at 40, so that's going to be our constant, our plus 40. How did I get 10 as our multiplier? Well, same as the last question, right? 100 subtract 40 is 60. 6 subtract 0 is 6. 60 divided by 6 is 10, right? So 10 is our multiplier. Y equals 10x plus 40. Is this partial or direct variation? Same as last time. It's partial because it has a constant, right? Our plus 40, and because it doesn't go through the point 0, 0. How much would it cost for Tasha to take 2.5 hours of lessons? Show your work. Well, just put in 2.5 for x in our equation. So y equals 10 times 2.5 plus 40. Y equals 25 plus 40. Y equals 65. So it will cost $65 for rentals and 2.5 hours of lessons. Does that make sense? Yeah, look in our chart, right? It's right in the middle of 2 and 3, 60 and 70, 65. Makes sense. Cool. Once again, the harder question, if Tasha paid $75, how long was she able to stay at White Mountain and get lessons? Same thing, but we're putting 75 in for the y, right? Because y represents cost of your day at White Mountain, right? X represents hours you're there. So 75 equals 10x plus 40. 75 subtract 40, right? Because you got to move the plus 40 from this side to the other side of the equal sign. And when you do that, you have to change the sign in front of it. So 75 minus 40 equals 10x. 35 equals 10x. Divide both sides by 10. 3.5 equals x. So if she paid $75, she can be at the park and get lessons for 3.5 hours. Which also, once again, makes sense when you look back at our table, right? Those numbers fit. I'm going to show you the graphs. I did the graphs for you as well, so to give you an idea what they're supposed to look like. Here's the first graph, right? Starts at $500 and goes down $40 each time. It's a straight line because it's linear. It has a constant rate of change, right? $50 a month, $50 a month, $50 a month, $50 a month. And that's why the rate of change was negative, because you're losing 50 a month, not gaining 50, right? That's why it's a negative 50. Second chart starts at 40 and goes up $10 for every hour you're there. The rate of change is positive. It's going up. That's why it's a positive 10 and not a negative 10, right? Once again, it's constant, 10 every hour. That's why it's a straight line. This should be simple enough, these graphs. We worked a lot of time on them, but there they are for you to look at. Last question, scatter plots. Basketball coach recorded the number of minutes each player was in the game and the number of points scored by the player. So all the data is right there. Determine the independent and dependent variables. That's always going to be your first step, because you have to know what to label each axis of the graph, right? So our independent variable is going to be minutes played, and our dependent will be points scored, right? The amount of points you score depends on the amount of time that you're playing in the game, not the other way around. So I made that chart for you. Let's take a look at it. Right here's what that scatter plot looks like. If I put in all the data, as you can see, on average, if you were to average all these points, they would increase on a line like that, right? The more time you're playing, the more points you're scoring. That's what's called a positive correlation, because as one thing goes up, the other thing goes up as well, right? So that's kind of what that graph would look like. The next question asks us, do you notice any outliers? There's a couple that I noticed. I noticed this one right here is an outlier, because it should be, if it follows the trend of going up, it should be probably somewhere more up around here, right? So that's an outlier, because it doesn't exactly fit the trend that the rest of the points are following. Same with this one here. This one not as much, because it's kind of close. Like if it's up here, not that big of a difference, but I put this one as well just because if it followed the trend, it should be up a little bit higher, right? But yeah, that's what an outlier is. When you look at the graph or the scatter plot, do any points not really look like they make sense? Does it look like that shouldn't be where it is, right? And when I looked at this, I saw this one and this one. Maybe you guys had a different answer. it asks you describe the relationship between minutes played and points scored. Well, clearly the more minutes you play, the more points you score. And like I said, this is known as a positive correlation because that one variable increases, so does the other. So hopefully that made sense. I just kind of wanted to post a video going over this assignment for the people who did it and were curious about the proper answers. Reach out to me with any questions about any of this kind of stuff. And we're going to kind of continue on with algebra and solving equations, combining like terms, all that stuff later this week. So we'll have a chance to practice those harder questions that you probably weren't too sure of before. And yeah, for those of you guys that did this and are watching this, keep it up because you're doing a great job. And yeah, that's it. I'll post another assignment to do either tomorrow or Monday. All right, take it easy.